Hello again. Welcome to my kitchen. And we are going to do another physics experiment. I decided to do laser Jell-O, not just because it's a cool name. This is actually based on content from our chapter 20 and 21. So I'm going to be looking at light refraction as well as just different wavelengths of light and how those are absorbed by other objects. So just kind of playing into what we can see and what we can't. And I'm going to do this with two very simple materials, Jell-O and a laser pointer. So I have two different colors of Jell-O. I'll show you right here. So I have perfectly formed red Jell-O, and then my green Jell-O, for whatever reason, broke apart when I was trying to get out of the container. I do have this little blob here, and I've tested it and we can still see the effects, so we're good to go. But I think I will transition over to my camera on my phone so we get a better view of what's going on. So I will do that now. So I wanted to go over the property of Jell-O to explain why we're using this material in this experiment. It's not just because it's bouncy and a really pretty color. So gelatin is actually colloidal, and that is a chemical property in which these larger molecules within the Jell-O are suspended in the solution itself, and because of that, we're able to reflect light through it. So you'll see that in a second, but that's extremely important and kind of a rarity in most substances, so it's enabling us to see light being reflected. So I will go ahead and turn my laser on and show you. Okay, so I have my laser pointer on, and as you can see, when I just have it just turned on with it going straight through the air, I can't see the beam of light. I can see an endpoint right here, but I can't see the whole thing traveling through. But when I shine it in the gelatin, I do see that pattern of light, that trail of the laser beam. Here, I think I can get a little bit better. There we go. So what's happening here? So we're messing with the index of refraction. So essentially, we are changing the speed of light. So in the air, it's going much faster, but then when it hits the material of the Jell-O, this thick gelatin substance, along with its property of having those molecules suspended and able to reflect light, is showing us this pattern, which really is kind of a rarity to see the trail or path of light. So it's giving us that ability here. Okay, so I wanted to go over one more point in the experiment, and that is comparing the red Jell-O and the green Jell-O. So we have a red laser pointer, and when I shine it through the red Jell-O, I can clearly see it. So when I go over to the green, though, it's very dull. You can see a little bit, but overall, it's difficult to see the pattern, especially compared to this red Jell-O. So what's happening here? So we're looking at wavelengths of colors being absorbed differently. So when I'm shining it in the red Jell-O, as you can see, the Jell-O is not absorbing those red wavelengths, so I'm able to clearly see the laser beam. But when I point it in the green Jell-O, that color is absorbing the red wavelengths, and there is a dimness, so it's not absorbing it fully, but overall those wavelengths are being absorbed. And so this is a really cool way to kind of see how color is perceived based on wavelength absorption.